Awesome, we'll get started. Welcome, thank you everyone for joining my session today titled The Highway to Hell is Littered with Unverified Passkeys. Before we dive into that, could I just get a show of hands of how many of you have had a disagreement with either a spouse, boyfriend, girlfriend, significant other, roommate over paint colors? Hold that thought, we will revisit that, but same here. My name is Jeff Corrigan. I am the Senior Product Manager of, this clicker isn't working. Nice. My name is Jeff Corrigan. I'm the Senior Product Manager of Identity Platforms at Yahoo. I've been deeply involved in identity since OpenID Connect was in its infancy and have since built, and helped others build products and features centered on open identity standards. For this session today, we are going to getting weird feedback, sorry. For this session today, we're going to cover a brief overview of Passkey user verification, as well as describe what the user verification options are. I put together a UV truth table that you can use to kind of help apply this to your own individual use cases. And then we'll discuss some of the considerations to take into account as you start to add passkeys to your flows. So overview of Passkey user verification. UV is a parameter that's sent by the relying party to the authenticator when they require FIDO authentication. It's essentially the relying party's way to say, hey, I might require or I may not require user verification to occur during the passkey authentication registration or authentication ceremonies. So when you pack the whole authn request, it actually looks a bit like this. There's a bit of latency. Have to do it the manual way. Actually looks like this. So user verification, you can send through your options, and this is kind of what it looks like on a lower level. So user verification is utilized during two passkey ceremonies. So the first is on registration. The relying party can have the authenticator perform like Face ID, Touch ID, or require the entry of a PIN or a password. And then the second ceremony where this applies is on authentication. And this is a way to basically say, the user that is utilizing the passkey is the same user that performed the registration ceremony. On that, there's a slight asterisk because, usually it's the same user, but in reality, most passkeys are entered into some sort of credential wallet, whether it's iCloud Keychain or Google Password Manager, and those individual services allow for you to add someone else to be authorized to use that account. So in reality, it might be the same user, but most realistically, it's probably the same user who is authorized to use the credential wallet. So after authentication, the passkey authenticator returns an authentication response object back to the relying party. This is encoded in this object is information that indicates if the authenticator actually performed user verification or not. And this is a way for the relying party to know whether or not the authenticator performed user verification. You'll see that there's an asterisk there as well because this is very platform dependent. So different passkey wallet creators have the control over their implementations. And so while it would be useful to believe that this is always done, even if the response object says that it was performed, there are known implementations out there that will always return true whether or not user verification occurred or not. And it is the relying party's responsibility to check this response object to see if the UV flag is present. As you can see here with the red text, it's simple flags, but it's the relying party's responsibility to check that if it's something that's critical for the particular flow that's being utilized. So what are the UV options? There's three of them. The first one is required, and required basically means that the relying party wants the authenticator to perform Face ID, Touch ID, or a PIN entry. And if the authenticator fails to do that, then the authentication itself is failed. The second option is discouraged, which which basically is the relying party's way to say, don't perform user verification. And that could be useful because maybe there's low friction, low risk flows that need to be, where you still need an authenticated user, and a passkey is useful for that. But the user verification might cause unnecessary friction. Didn't put an asterisk on here, but it's also worth pointing out that discouraged doesn't mean that it will never occur. It just means that it's not desired by the relying party. But there are implementations of hardware security keys where biometrics are just built into the key itself, and so that biometric check will always happen just as a result of the nature of the hardware. And then the third option here is preferred. Preferred means that the relying party doesn't really care whether or not user verification occurs or not. And in doing so, it's essentially saying, if the hardware and the credential wallet and everything is already set up and the biometric inputs are available, then perform user verification. But if they're not available, it's okay to continue that authentication process. And when the response objects gets sent back to the relying party, it's not considered a failure to authenticate. Also, very worth pointing out here that using preferred is a lot of times the user verification does occur, but it's also dependent on your hardware, how you're using your hardware. So for example, I can close my laptop and plug into a docking station, which is how I run my work laptop at home using external monitors. And if I'm prompted to do a passkey authentication because my lid is closed, my Touch ID sensor is no longer available, so therefore user verification doesn't occur. And so it's important to remember here that these three options are applicable to both the authentication and the registration ceremonies. So I wanted to put this together in a form that kind of outlines just some of the considerations. And so I put together what I call truth table, user verification truth table. And it's a lot of text. Don't be overwhelmed. I'll kind of break this down and explain as I go through. So from columns here, we have registration and authentication on the left side. And we take the combination of registration plus authentication, and we look at how that impacts the downstream items on the right side, which are the authentication confidence, user friction, and step-up confidence. So looking at this, first, for registration, we've got all of the possible possible permutations here. So required, preferred, and discouraged. And we take that and add that with authentication, which is also required, preferred, and discouraged. And we put those together, and that gives us the ability to run through these permutations and see how that impacts the right side. So here, outlining the overall impact, looking at this, I've seen this table a lot of times. It's a lot to take in, so we'll start with user friction first, just because it's a little easier to consume. So here we're outlining the overall impact to user friction by requiring or discouraging user verification for both the registration and authentication. And again, important to point out, preferred is not a guarantee that UV will occur, but for the purpose of this table, when we try to apply a level or calculation of the friction, we use medium just because it's hard to determine what the user friction would be based on whether or not verification occurs or not. And it's also worth pointing out here that for user friction, when we say the highest user friction, that in most cases or in many cases, this is going to be something simple like holding your phone up for Face ID or doing a Touch ID input or a PIN. So user friction, even when we say highest, it's not necessarily something that is incredibly disruptive, but it is just something to kind of keep in mind as you're planning out your passkey rollout. And so you see here, required provides the highest friction, discouraged provides the lowest friction, user friction, and in the middle when we have preferred, it's kind of hard to determine because again, it depends on whether or not the authenticator actually performs UV. So let's have a look at how these combinations impact your authentication confidence. So the combination of UV options has a really substantial impact on confidence. Authentication confidence here being that this is your ability to assess that the user performing the authentication is the same user that registered the passkey. So as you go down through the list, the extremes are easiest to assess. So required has the highest confidence, and discouraged has the lowest confidence. And we end up with some interesting consequences, though, when we lead with preferred or discouraged for the registration ceremony. So as you can see in this first row where preferred was chosen as the registration UV flag, but required is the authentication UV flag for authentication, the confidence is actually inverted. It gets even more inverted when you select discouraged for the registration ceremony, but then required is being chosen for auth-in. This actually kind of makes sense, though, when you think about it. So, how can you have authentication confidence if you discourage UV on registration? And if you did that, why would required be chosen for authentication? Maybe there's a good use case for that. I'm not really sure, but I don't think that this would be intentionally implemented. So, if you do have a use case for it, I'm happy to hear what it is, just to kind of learn as well. So if the highway to hell is littered with unverified passkeys, they were probably created using preferred. I used the word indeterminate here in the center. It's not clicking. Sorry, my clicker doesn't work, and so my transitions aren't working right. There we go. I used indeterminate here looking at preferred because if you're using this to kind of plan out up front, how passkeys can be applied and the authentication confidence can be applied to your flows, it's really hard to say whether or not UV is going to actually happen or not. Preferred on its own isn't necessarily terrible, but if you do need to use the response on registration to identify if UV was performed, and then apply that to whatever your confidence requirements are for the particular authentication use case. And this is actually the same with authentication. So if you use the authenticator response, you can make on-the-fly decisions as they apply to your specific use cases. The downside to that, though, is if you did do this solely based on whether or not the response object contained the UV flag as being true, like you would also have to implement the fail scenarios for that particular flow in order to actually get them up to the level of confidence necessary. So preferred might not actually be correct for a particular use case. Also just pointing out, so using preferred without ever checking for user verification could lead to an account takeover scenario where for example, you log into an enterprise identity provider, go into that system's account settings page. If you're using a password manager, which is pretty common, like your username and password part of that authentication flow is probably going to be auto-populated for you. And so anybody could walk up to a laptop in, say, like a corporate environment, or office environment, or home even, and go into the settings of an account, add a passkey, which they could then use later for authentication into that account and remote access. So, getting this right is important, and it's important to apply this to the correct use cases. So, lastly, here is the ability to get a higher confidence level from the passkey, and that means that if you, for example, did required preferred for most of your flows, like you can still require UV on an authentication for a more riskier or higher confidence scenario, and have high confidence that the user authenticating is the same one that registered that passkey. So with preferred for registration, we actually say step-up confidence here would be a maybe, because it really depends on whether or not you checked and stored whether or not UV was done when the registration ceremony occurred. And a passkey's confidence level for authentication cannot be any higher than what it was at its registration time. And again, that's based on user verification actually being performed. So if we put this all together, the entire truth table kind of looks like this, with all of the options, again, required, all the way down through discouraged. And We've got gray in the middle. The paint colors thing, it's not accidental that preferred is gray. It turns out like the entire interior of my house is painted gray, and my wife and I disagree on where that paint should be painted because like we don't have a lot of natural light, and so there are areas where that particular color actually doesn't work well. It makes the rooms look smaller, and we disagree on where that gray needs to be applied. And just like the paint colors, you need to apply this to your individual use cases because preferred probably isn't something that should be painted everywhere. And funny enough, like I had to mix up a gallon of paint, so I went to the basement to get the paint codes to take it to the hardware store. And the paint color is actually called agreeable gray. So like you gotta imagine, like that's a courageous name for a product. So let's see how this applies to your authentication use cases. So some things to consider here. Think back to the truth table, your account life cycle. So you have registration, subsequent, just general authentication scenarios, modifying sensitive account settings, or modifying information for like payments or addresses or whatever applies to your use case. So one of the things to consider here is what would be the impact to a user's account and your organizational's security if you assumed UV would be occurring, but you didn't check. Second consideration is what's the risk level of the actions the user's performing after authentication. So are these account security changes, or is it music preference changes? So consider that up front as well. And then third area here would be if doing is typing in a PIN or a password as a part of a low-risk authentication flow, is that going to have an impact on your conversion for whatever particular actions the user is going to be performing after they're authenticated into your system? So there's user impact, user friction and impact to your flows that also needs to kind of be taken into consideration. And again, getting this wrong could have consequences down the road. There's a lot to consider, but the first step is really just knowing that this functionality exists, understanding how it works, and then taking it back and applying it to your use cases. So takeaways here, the UV flag gives the relying party the ability to require biometric or PIN verifications of the user during both the registration and authentication ceremonies. It's not quite as straightforward as it seems at face value, though. It is the relying party's responsibility to check the UV flag after authentication and registration. Preferably, that information should be persisted, so you have it later, again, because you may down the road have the need to be able to utilize that same passkey for step-up confidence. And then, use that truth table to validate your authentication flows. Will you need to be able to do step-up confidence in the future? How is this going to impact specific flows that you have? Is it okay if UV doesn't happen during authentication? Because sometimes that's perfectly fine and that's valid. And so just take into consideration all of those items. And with that, I will open it up for questions.
I think you mentioned the default, if nothing is set, it is preferred.
Right.
Which puts you into that high.
Yes.
That's kind of a key thing.
Yes. So repeating question, thank you for pointing that out. So if you do not set these flags, it defaults to preferred for both registration and authentication, which means if you're enrolling a new passkey, or if you're rolling this out and you didn't know that this existed, or your implementation is using preferred, it's very well possible that that passkey may not have had user verification performed when you did the registration ceremony. So that does have later impact, again, if you need to be able to have step-up confidence for that passkey and know whether or not UV occurred. Go for it.
When you say preferred, is it a skippable experience, or are you talking about slow verification?
So the answer is yes. The answer is actually, it really depends. And it's not even like a specific passkey vendor, right? Like at Yahoo, we have written our own backend stack for WebAuthn and Passkeys, but even still, like we are relying parties to Google Chrome and to Android and to iOS and to iOS keychain. So it really depends on the individual, the credential store where that passkey is saved and where it's persisted, because like that's the level of where that decision making happens. And so, most of the time, at least in my experience, if you set preferred, as long as the hardware is available, it will perform the user verification. But again, it also depends. Like if your laptop lid is closed, maybe you haven't set up iCloud keychain, or a whole myriad of other reasons, the user verification just simply won't occur. The passkey can still be authenticated and it will not fail, and that's kind of why preferred exists. It's like do user verification if you can, but if you can't, we'll still allow the authentication to occur and not fail it.
Is there a way to ask for a specific authenticator, or is it just like you get a yay or a nay?
So the question was, is there a way to ask for a specific authenticator? I don't believe that the relying party, well, that kind of goes into a larger array of discoverable versus undiscoverable. And then again, there's the reliance on like the browsers, for example, because you can on certain platforms register more than one passkey for a particular service. And when you get the prompt, the passkey prompt, essentially, you can select whether or not it's coming from like iCloud keychain or whether it's coming from Google's password manager. So there is some selection there, but on the it's again kind of dependent on the platform. And I saw, yes.
I was just wondering, did you give some use cases for the discouraged?
So you have the question was use cases for discouraged. I would see these as low friction, low risk type of things. So maybe you have a marketing campaign and the emails get sent out, you click, it loads your application, and as a part of that, like the application just needs to be authenticated, but it's a marketing campaign, so you don't want a lot of friction because you're trying to provide conversion for whatever that campaign is supposed to be for. And so discourage could be pretty useful for authentication there. I would, my own recommendations would definitely be leaning towards required for all registration ceremonies as a personal preference. Plus, it gives you the benefits later of having, step up confidence in that. But, discourage does have a place for certain things, especially on the authentication side.
My question kind of ties into that. Like, I'm thinking about progressive profiling, and if there might be a use case for registering a passkey without user verification, but then maybe adding that later. Do you see if that as a potential option, or does that have too much any risk?
Yeah, so the question kind of repeating back is there a use case for doing discouraged on registration and then later adding it for authentication? Is that correct?
I don't know if it would be adding it for authentication or like a next level of registration in order to add it.
So if the passkey is registered using discouraged, you wouldn't really be able to add that flag after the fact. Like you can still perform authentications with it and use the response object to see if the platform did user verification on subsequent authentications. But you're doing user verification for a passkey that never had a user verified when it was created. So like it is kind of an inverted confidence. I saw another one.
If it's a required, how does the syncable impact that? In registration, is that syncable still then carried that it was required originally?
So if it's syncable, that's a good question. I think the answer would be that if it's synced, like that information should be a part of whatever platform is providing that synchronization mechanism. But I'm not sure. I can look it up and get back to you, though.
So I'd like to kind of address a couple of the answers that you've given. On the user verification, that is just the signature during that event that the authenticator
Right.
So in the question of why would you use it as discouraged, you might be wanting to have web opt-in operate as a second factor only flow. So if you're using username plus password and you need a second factor, like Google rolled out security keys for many years, that would be one of those scenarios. On the question about how do you like incrementally build that profile, passkeys are designed to be destroyed. So you could create a new passkey
Right.
with the UV verification required the next time you go on.
Right.
And so I think there's a little bit of passkeys give you signals based on what they were. They're easy to create, destroy, and then you have to verify the attestation to understand what is going on with the attributes that the authenticator is provided.
Right.
And so there's a couple answers here I think that are unfortunately a little misleading, and I want to make sure we kind of clear up that.
Sure. Thank you. Yep. Awesome. Well, thank you.